Hey, you are welcome. Today we'll discuss one concept which is a name reaction. It's called Barton Nitrite Photolysis. So the general reaction is this which I described here, that a delta hydrogen atom, alcohol is taken with having a delta hydrogen atom, which is treated with NaCl first, and then after that photochemical condition, and then a dilute acid. So the final product will be keto. We will discuss the mechanism. The proposed mechanism is here. First, the NaCl, a nucleophilic substitution reaction takes place. What happens here? This OH group attack this nitrogen, and Cl removes, and after that a nitroso compound, ONO compound is formed, that is a nitrito compound, and which on treated with HNO break this bond. This bond is quite weak because this oxygen has 2 lone pair of electron, nitrogen also have 1 lone pair of electron. So the interelectronic repulsion creates this bond quite weak, and in photochemical condition it easily breaks, and two radical is formed plus NO radical. Now this radical is converted into another radical via a 6-member cyclic transition state, which is this, and the new radical is this radical is formed. Now this nitroso then attack at this radical, and then a nitroso compound is formed, which undergo keto, a nitroso oxime protomerization, and a oxime is formed. Now this oxime, treated with dilute acid, the corresponding carbonyl compound is formed, that is a beta carbonyl alcohol, which is our product. If it is a ketoxime, then the beta keto alcohol will be formed, and if it is an aldoxime, then the beta aldehyde alcohol will be formed. Now the hydrolysis mechanism of oxime is very easy, as you know. You can see here the mechanism. I'm not going to detail of this mechanism. Now will come one question which came in GATE 2021, the major product formed in the following reaction. So we already discussed the Barton photochemical, the Barton photolysis reaction. So this is the Barton photolysis reaction. First, we already drawn the mechanism. In this question, you can see here the first OH will converted into the ONO, that is the nitrito compound, which when treated with HNO give this radical, and this radical will be converted into this radical via a 6-member cyclic transition state, and then the nitroso compound will be formed. This is nitroso, and which will undergo tautomerization to an oxime, which on hydrolysis gives the corresponding aldehyde. Now here a trick is there. Now if we see the question, we already know that the delta hydrogen atom is abstracted during one radical is converted into another radical. So here if we see that 4 types of delta hydrogen atoms are there, that is this is alpha, beta, gamma, delta. This is also delta. Now alpha, beta, gamma, delta. So you can see that 3 types of also alpha, beta, gamma, delta. This is also delta. So you can see that 4 types of delta hydrogen atoms are there, but only this product will be formed, because this delta hydrogen atom will participate. This is because for this delta hydrogen atom 6-member cyclic transition state is possible. For other delta hydrogen it is not possible, so this product will be formed only. Now we'll come to some examples of this reaction. Now this is an example 1. If this compound is treated with NaCl, which is converted, this hydroxy group will be converted into ONO, which undergo photochemical Barton reaction. And here also, if you see, this is alpha, beta, gamma, delta. This is alpha, beta, gamma, delta. So two types of delta hydrogen atoms will be there. So which will be the product? Both the product is formed here. The competitive reaction takes place between these two delta hydrogen. Now if this proton is abstracted, then the corresponding product is this. And if this proton is abstracted, then the corresponding product will be this. Now here this radical will attack into this carbon, and it will be form the corresponding then the nitro. So then the NO radical will attack at this carbon, the corresponding oxime will be formed. Now we'll come to example 2. For this, this is if you see here, this is alpha, this is beta, this is gamma, and this is delta. So from this hydrogen, it will product will be formed here. So this will be the product. The oxime will be formed in this carbon. Now we'll come to the next example. In this compound, this is the alpha, this is beta, this is gamma, and this is delta. So now this is below the plane, and also this group is below the plane. So 6-member cyclic transition state is possible, as these two groups are both below the plane, and that's why the oxime will formed in this carbon. Now we'll come to the next example. This is you can see here that this hydroxy group will be converted into ONO. Now with respect to this hydroxy group, this is alpha, this is beta, this is gamma, and this is delta. Now this is alpha, beta, gamma, delta. This is alpha, beta, gamma, delta. So in 3 types of delta hydrogen atoms are there. So in this case, which will be the product? Here both these 3 delta hydrogen atoms are above the plane, and this hydroxyl group is below the plane. So in this case, this is not possible. So another delta hydrogen atom will be here. This is below the plane. This is also delta carbon. So with this hydrogen, this product will be formed, and the oxime group will be come in this carbon. So guys, if you have any doubt regarding this video, please let me know in comment box. And to have such videos, please subscribe my channel. Thank you. Have a good day.